Good evening. Welcome to the week 2 problem solving section for this course availability and management of groundwater resources. So those of you are new to this class, my name is Shruti and I'm a PhD student from IIT Palakkad, and I will be helping you with this problem solving session. So problem solving sessions, basically we'll be doing sample problems that will help you with assignment problems that are the assignments that are assigned to you every week. So it will more be like an interactive question and answer session where I'll be giving a few questions and you can do it along with me, and then we can discuss about the solutions. So last week we had discussed about the first week's lecture, the questions that were related to the first week's lecture. And this week we will be discussing about the lectures that were taken in the second week of this course, which involves the geological formation as aquifer that has a lot of portions that are covering about the various types of geological formations, various types of rocks, and the terms and terminologies that are related to it. So we'll move on to the question and answer session. It will be like, in order to make it interactive, I'll be providing some time for you to do the questions. Even if you are, if you can put in your answers in the chat box. Hello, Bhargav. Okay, I hope I'm audible to you. So, like I was saying, this week's problem solving section will be on topics that were covered in week 2, which is about aquifer and other geological formations, and also about different types of rocks. So we'll be going into the questions. You can type in the answers in the chat box if you know them, or even if you don't know them, what seems like a right answer, you can put your answer in the chat box, and then we can discuss the solutions. Moving on to the first question, the geological formation which yields only insignificant quantity of groundwater, what is it called, is the question. You can put in your answers in the chat box, and then after that I will be moving on to the solution. Hi Ishwar. So this is the first question. We'll take a minute to read the question and figure out what the answer is, and you can put in the answer in the chat box, and then we'll move on to the solution. So the question here is, what is the geological formation which is yielding only an insignificant quantity of groundwater? Is it called an aquifer, aquifuge, aquiclude, or acutard? So just type in whatever you know and which option seems right to you in the chat box, and then we'll go on to the solution. I'll be explaining what all the terms mean anyways. So if you, or if you want to, you can try guessing too. Hi Vagisha. But I'm not sure if I'm pronouncing your name right. Okay. Hello anyways. So for those of you who have joined late, I'll be discussing the questions for the second week's lecture related to the second week lectures. So these questions I'll be giving one by one of these, showing one by one of these questions. You can just type in the answers in the chat box if you know the answer, or if you don't know, you can take a guess, and then we'll move on to the solution. So the first question here, it's this is the first question here. What is the geological formation that yields only an insignificant quantity of groundwater? Don't worry if it is wrong or not. There's nothing to lose. Doing with these practice sessions, it's actually going to help you not go again and revise back. Once you go through these problem solving sections, I don't think so you'll have to repeatedly keep studying these portions. So it's covering majority of the topics that are covered here. So it will be a good practice for you also. If you know the answer, please put in the answers in the chat box. Okay, I think I don't see any answers. So let's move on to the solution. So the geological formation which yields only insignificant quantity of groundwater. Before going into that, we can see four terms over here, which is aquifer, aquefuge, aqueclude, and aquetard. Now just let's see what all these terms are. So if you see the surface of the soil and what is under the surface of the soil in terms of geological formations, the various geological formations are what was mentioned here: aquifer, aquetard, aqueclude, and aquefuge. So aquifer is nothing but it is permeable formations that is capable of holding a good amount of water, and again it is also capable of transmitting or yielding a very significant amount of water, lots of water. So when we drill a well, or when we dig a well or something, we are actually getting the water from the aquifers. So this is why we say that aquifers are this permeable formations which is capable of holding as well as yielding water. Now let's move on to the next term, which is an aquetard. Aquetard, as you can see in this picture over here, these are semi-permeable structures. Okay, they are capable of yielding water, but they cannot provide water as good as the aquifers. So they will have some amount of water in it, but it doesn't provide as much as water an aquifer can provide. So that is what an aquetard is called. So by definition, it is a formation where seepage is possible, and its yield is not very significant as you compare it to an aquifer. Now the next term is aqueclude. Aqueclude is something like a clay material which can retain water. Water will be there, but you will not be able to extract water from it at any cost. So in case you're drilling a well into a clay soil, even though there might be water particles in that formation, you will not be able to obtain or extract water from such formations. So such formations are called aquecludes. So we checked into aquifer, which has got enough and more quantity of water. It can provide also water, can store as well as transmit water very significantly. Then there is aquetard, which is having water, but its yield is not as significant as an aquifer. And we talked about aqueclude, which are semi-permeable formations which can retain water, but it will not transmit water at any cost. So there is also a fourth category called aquefuge. Aquefuge, it cannot store water, neither can it transmit water. It's those rocky things which has no pores in it. It's very compressed, it's very consolidated, there is no pores in it. This kind of formations are incapable of storing water. So these are the major four kinds of geological formations that we're focusing on. It's aquifer, which has got a good amount of storage and transmitting capability of water. Aquetard, in which seepage is only possible. It does not provide as a good amount of water as an aquifer does. Then is aqueclude, which can retain water, but it cannot transmit water. Water flow doesn't happen through such materials or such formation. And aquefuge is an impermeable formation which is neither containing water nor does it transmit water. So our question was, which geological formation will yield only insignificant quantity of groundwater? So the answer here is acute tart. Like we discussed, it's not aquifer. Aquifer gives a good amount of significant quantity of water, but acute tart gives only an insignificant quantity of water. So that was the first question. Moving on to the second question. In consolidated formations, water may be yielded through cracks which are termed as. Again, you can put in your answers in the chat box. Let's make this a little more interactive so that it will be interesting for you as well as for me. Okay, I'm glad there's one answer. Great, Vajisha. She's given fishers as the answer. If there's someone else, come on. You can direct message it to me or you can put it any way you want. Like I said, I've been doing these questions with me will be helpful to you also. You won't need to keep revising these portions later on. Okay. It looks like there's only one answer. Thank you, Ajisha. So, in consolidated formation, water may be yielded through cracks, which are termed as fissures. Like Vajisha said, fissures are these cracked portions you can see in geological formations. It is through that we can get water. It is one way to get water. You can get water from other means also from these formations, but the cracks are called fissures. Now moving on to the third question, again about the geological formations. Which of the following geological formation contains and readily yields water to our tube wells? So I discussed earlier about the whatever four kinds of geological formations that you can see here. So based on that, maybe try to answer what is that formation called, which is capable of storing as well as readily yielding enough water to our tube wells. Okay, thank you, Ajisha. Am I pronouncing your name right? Is it Vajisha or Vagisha? Vagisha itself, I hope.
Vagisha.
Vagisha. Okay, okay. Sorry about it. Okay, thank you, Vagisha. Okay, so the answer, what she said is right. It's aquifer. Like we discussed earlier, aquifers are the most yielding capable formation. After which there's acute tart. Then there's aquinclude that can just retain water but not transmit water. And there's aquifuge, which does not have water at any level. So the correct answer for this question is aquifer. Vagisha was right. Okay, now let's move on to the fourth question. Rhyolite is an example of which type of rock? So here there are three types of rocks that are provided. Sedimentary rocks, igneous rocks, metamorphic rocks. Or is rhyolite not a type of rock itself? Again, guess some answer. If you don't know the answer, there's nothing to lose. So type in your answers in the chat box. Okay, thank you, Vagisha again. Ishwar thinks it is igneous rock. Let's see. Any more answers? Om Parmar. When you can answer. Okay, there doesn't seem to be any more answers. Igneous. Okay, let's see what the answer is then. So yes, the rock type is rhyolite is an example of igneous rocks, or not igneous rocks. So igneous rocks are those rocks which we all know are formed when the magma or lava solidifies with or without crystallization. Crystallization is nothing but forming crystals. When the liquid form is getting converted, is solidifying, they'll form these very well structured solid particles called crystals. So that is how igneous rocks are formed. The igneous rocks can be formed on the surface as well as under the surface. When it is formed on the surface, it is called extrusive rocks or volcanic rocks. And when it is formed under the surface, it is called intrusive rocks or plutonic rocks. It will be good to remember these terms, plutonic and volcanic. Plutonic means the ones, the solidification is happening under the surface of the earth, and the igneous rocks formed as a result of this is these are called as plutonic rocks or intrusive rocks. And the ones where the lava is reaching the surface of the earth and then it is solidifying, we call it extrusive or volcanic rocks. You can also see examples of igneous rocks provided over here: granite, rhyolite, gabbro, and basalt. So these are four examples of igneous rocks provided. So rhyolite is an example of igneous rocks. And the other types of rocks that were shown over here in the options were sedimentary rocks. Sedimentary rocks, again, something that we have studied in our school days. These are weathered particles of rocks or any other weather particles. They will be transported by various agents and then they get accumulated in a place to form sedimentary rocks. So these examples of sedimentary rocks provided here are sandstone, limestone, siltstone, and halite. Again, if you can remember the examples, it will be useful for you to do these problems. So these are probable questions that can come during the exam. So that was about sedimentary rocks. Then there is metamorphic rocks. Metamorphic rocks are rocks which are igneous or sedimentary rocks. When they are exposed, they are subjected to high pressure, different levels of pressure and temperature. The chemical physical structure of it itself changes and it forms a new type of rock, and that rock type is called the metamorphic rock. Metamorphosis means change. So rocks which are changing in its physical and chemical structures will form new types of rocks called metamorphic rocks. Some of the examples are marble, slate, gneiss, and phyllite. So our question was, what rock type is the rhyolite? The answer is igneous rocks. Okay. So let's move on to the next question. The fraction of water that is held back in the aquifer is also known as. So this is some property of the soil formations. The four options have been given. It is porosity, void ratio, specific retention, and specific yield. So the fraction of water that is held back in the aquifer, what do you call that? Is it called porosity? Is it called void ratio? Is it called specific retention? Or is it called specific yield? Those of you who have a background into civil engineering or water resources or geotechnical will be familiar with these terms. Others can guess it. And then we'll be going into detail about each of this term. So what do you call the fraction of water that is held back in the aquifer? There's some amount of water which will, the aquifer, if it has to have water, it is obtaining it from the rain. So rainwater is getting into the soil and then it is getting stored in the aquifer. So some amount of water is being held back in the aquifer. What is that called is the question over here. Okay, I'll move on to the answer. So the answer to this question is specific retention. So let's go into the other terms as well. So the first option is porosity. What is porosity? Porosity is nothing but if you take a soil sample, say if you're taking 1 meter cube of soil, then that soil will consist of the solid particles. It will consist of pore spaces in between the soil particles. And if there's some amount of water in the soil sample, there'll be water also inside those pores. So the ratio, that is, when you estimate the amount of pores in this 1 meter cube of soil sample, and when you divide it with the total volume of the soil, which what we are taking here is 1 meter cube. So the volume of the pores to the total volume of the soil sample is what is called as porosity. So porosity again is nothing but the ratio of the volume of the pore spaces available in that soil sample to the total volume of the soil sample. That is porosity. Now moving on to the next term, which is void ratio. Void ratio is nothing but, again we are taking a soil sample. Like I said, there is the solid particles, there is the pore spaces, there is also water particles in it, there is water content in it. So it is entire soil sample has the volume of the solid particles, volume of pores, and volume of water as well. When you find the ratio of the volume of the pore spaces alone, volume of the voids to the volume of the solids. Porosity was volume of the pores to the volume of the entire soil sample, while void ratio is the volume of the voids to the volume of the solid particles in the soil sample. Then we call it the void ratio. So that was about porosity and void ratio. Now porosity is related to two other terms called specific retention and specific yield. Let's see what specific yield is first. So like I said, aquifer is comprising of water. How is it getting its water? When there's precipitation happening, this water is entering the soil particles and it is moving down to saturate the soil sample, which saturate the aquifer. Now, the volume of the water that can be released by the gravitational effect from a volume of aquifer is what is called the specific yield. So when this water enters the soil sample, some amount of water is drained out because of the force of gravity. So whatever is that volume of water that is being drained out of the aquifer, when you consider a unit volume of the aquifer, is what is called as a specific yield. Now, specific yield is again the volume of water that is lost as a result of gravitational effect to the volume of the aquifer, to unit volume of the aquifer. So again, some amount of water that is lost, that volume is called specific yield because of gravity. Now, some amount of water will remain against the force of gravity. Two forces will play. Two major forces is the solid particles, the whatever soil particles are there, they are capable of attracting water particles onto its surface. So that water will remain in the aquifer or in the soil sample. Again, pore spaces are there. Inside that pore spaces also water will get retained. So such water that is retained in this aquifer against the force of gravity is called as specific retention. So the fraction of water that is held in the aquifer against the force of gravity. Whatever water is flowing out as a result of gravity is called the specific yield. Whatever water remains is called the specific retention. So these four terms are very important when it comes to an aquifer. Repeatedly, what is an aquifer? Accuclude, accufuge, acutard. That is one common question. And porosity, specific retention, and specific yield are also important terms when it comes to this portion. We will be doing a lot of questions that is like interchanging the terms here and there, which will help you familiarize with these terms. So that was about this question. Now moving on to the sixth question, which is again based on these four terms. What type of geological formation is a granite? Granite comes under what type of geological formation? Is it an aquifer? Is it an accufuge? Is it an acclude? Or is it an acutard? We can think about the granite rock, granite sample. What kind of, I mean, we use granite and all in house constructions. You can think about if you pour water, what happens to it, and then you can maybe choose an option. Is it capable of storing water? Is it capable of yielding water? Or does it allow water to enter through it? Based on that, maybe you can provide an answer. Come on. Please type in an answer in the chat box. Vagisha and Ishwar. Whether it is right or wrong, it doesn't matter. Right, Vagisha, it is correct. Aquifuge. It's a very impermeable formation, so it comes under aquifuge. So let's also see some examples for the other formation. Now, aquifer, again, sand and gravel beds are good materials for transmitting as well as yielding water. So, some of the examples of aquifer are sand and gravel. Then we talked about acutard, which is capable of water seepage is possible. Clay lenses interbedded with sand. I can show you an example. This is not a clay lens. This is a sand lens that is interbedded in silt. So it is clay lenses is nothing but a patch or a portion of clay will be in between these sand particles, and such a formation, such an entire geological formation is also an example for acutard. So that is for acutard. Then acufluids are ones which can retain water, but it cannot transmit water. There's no movement of water. So example, best example for an acufluid is clay, and then granite is an example for acufluids. It is completely impermeable, so you can't. There's no water movement at all in this one. Okay, there's one more entry. Sheha, hi Sheha, welcome to the session. You can answer the questions what you see on the screen and type in your answers in the chat box. So we are moving on to the 7th question. Which one of the following is the correct expression? So you can see here there are three major terms provided: porosity, specific retention, and specific yield. There's a relation between these three terms. What is the correct relation? I mean, out of these four options, which is the correct relation is the question. You can again type in your answers in the chat box, direct message me, or you can put it to everyone. Any way is all right. So is porosity equal to specific retention minus specific yield, or is it a sum of specific yield and specific retention, or is it specific yield minus specific retention, or is it a product of specific yield and specific retention? Again, this you can think about it. You can think about the definitions of specific yield and specific retention. We talked about what specific yield is. It is the water that flows out. And we talked about specific retention. It is the water that is stored in it. I mean, that is retained. So porosity is again the ratio of the volume of the pores to the entire volume of the solid or the soil sample. So how will it be related is something you can think about. Otherwise, we'll go on to the solution and find it out. Okay, so let's move on to the solution. So specific yield, like I defined earlier, is the amount of water per unit volume of aquifer that is going to drain off under the influence of gravity. So if you take 1 meter cube of aquifer, then how much amount of water is going to drain out of it under the influence of gravity is what you call as specific yield. Now, specific retention again, if you take 1 meter cube of aquifer material, is the amount of water that is retained in it. Again, here they're mentioning it is retained on the surface of the grains as a film, or it is held in the openings by molecular attraction. So whatever water is retained in the unit volume of the aquifer is what is called as a specific retention. Now, porosity is equal to the sum of specific yield and specific retention. So you can see the formula over here. Vd by Vt. Vt means it's the total volume, and Vd is the volume of the water that is draining out. This is the volume of the water that is retaining, and this is again the total volume. The volume of the water that is draining out plus the volume of the water that is retaining will give you the total volume of the water that is flowing into the soil. That divided by the total volume of the solids is what is giving us a value of the porosity. So the relation between, even if you don't get a link with it, porosity is equal to specific yield plus specific retention is a very important relation. A lot of problems come. They give the specific yield and the porosity, and then you have to find the specific retention. So a lot of small numerical problems also come with relation to this expression. So specific yield plus specific retention is equal to porosity is one expression that you'll have to always keep in mind. Okay, so the correct answer is porosity is equal to specific yield by plus specific retention. Excuse me for a second. Okay, so let's move on to the 8th question. Specific retention of groundwater is larger in coarse grained soil. Is this true or false? So we learned what specific retention is. Specific retention is when the water is held by the soil particles. The molecular attraction of the soil particles will retain water. That process is that water amount of water is called specific retention. Now, if the specific retention of the soil has to increase, what should be the size of the soil particle? Should it be big or should it be small? Then we can see coarse grained soil, what is the size of the particle? Compare it with clay, what is the size of the particle? What happens to the molecular attraction, or what happens to the amount of water that is retained by a large particle or a small particle? And based on that, maybe make a relation if the statement is true or false. Specific retention of groundwater is larger in coarse grained soil. Is the statement true or false? Is the question. See, there's nothing nothing to be ashamed of if your answer is wrong. So go ahead and give the answer. You can direct message me also. Ishwar, Sheha, Vagisha, please type in your answer. Kind of makes it boring when there's no interaction. So please do it. Okay. Right. Right. Yes, your analysis is kind of right. Coarse grain soil, the void spaces will be larger. The water has a capacity to drain out of it more easily. Ishwar has said false. Okay, thank you for your answers. Let's move on to the solution. So the answer false is right. Let's see why it is. So like one of the reasoning is what you have told, Vagisha. So why is that happening is what we'll see now. Now, I think we are aware about the concept of surface area. So for a huge particle, when the particle, this is the surface area variation varying from coarse grained sand to clay particles. Coarse grain particles are bigger in size. Clay particles are smaller in size. What happens to the surface area when the size of the particle reduces? The total surface area is going to increase when the size of the particle keeps on decreasing. So you can see in this picture over here, when you take a one whole big cube, millimeter cube of say particle, the surface area is going total surface area is going to be 6 mm square. As when you divide it equally into two parts, the total surface area is going to be 8 mm square. So here the total surface area is increasing as the particle size decreases for a particular volume of the substance or the soil. So what happens when the total surface area increases? Every small particle is going to hold some amount of water. So the water held by every particle is going to be a lot more than the water held by this one particle, because the total surface area is higher in smaller grained particles. So that is why it is false over here. Specific retention. The large size particles are not able to retain as much water as a small size particle like clay can do. So the specific retention keeps on increasing as the particle size decreases. So it is not large in coarse grained soil. uh, Retention capacity of coarse grained soil is lesser. We know that if you take the water and pour it through sand, all of it drains off when compared to clay. Clay, the water keeps getting retained. So the answer for this question is false. Specific retention of groundwater is larger in fine grained soils or soils with small particle size like clay. Okay. So all these questions will be possible if you correctly understand what specific yield and what specific retention is. So moving on to the next question. Which sedimentary rock is said to be the best kind of formation for groundwater? Is it sandstone, limestone, shale, or gravel? Again, this is a very theoretical question, something you just need to know by heart. It's not something that you need to, think a lot about. So sandstone, limestone, gravel, and sandstone and limestone are example. All these are examples of sedimentary rocks. Out of this, which one is the best formation for groundwater? It's a question for this one more person who's entered newly. So for you, please type in your answers in the chat box. You can direct message me or you can put it for everyone to see. Whether you're right or wrong doesn't matter. After that, we can discuss the solution. Okay, Vagish has given one answer. Swad is also given an answer. Okay. I hope there's no more answers. So let's move on to the solution. The correct answer is gravel. Gravels are considered to be the best kind of formation to yield groundwater. So again, gravel also, not all gravels are giving us the same. I mean, it is the best for groundwater in gravels itself, based on how they are packed. I mean, how the packing is, how they are distributed. Everything matters when it comes to the formation for groundwater. But if you talk about the type of sedimentary rock which is best for giving us or yielding a lot of groundwater, it is gravel. So this is sandstone, limestone, shale, and gravel are examples of sedimentary rock is another takeaway point from this question. Let's move on to the 10th question. What is the volume of groundwater which can be extracted by gravity drainage from a soil stratum when expressed as a percentage fraction of the volume of the soil stratum? So again, let's go back to or try to remember the definitions of the terms that we have discussed. Volume of water that can be extracted by gravity from a soil stratum. What could it be? Is it available water? Is it specific yield? Is it field capacity? Or is it pellicular water? Type in your answers in the chat box. What about Ankita, Ishwar, Sheha? Do share in your answers too. Or have you kept the video? I mean, have you just participated and left the screen? I don't know. Maybe I'll assume that you've done that if there's no response from you. Okay, it's okay. I was just kidding. Don't get scared and run off now. Okay, we got two answers. Vagisha has given B, specific yield. Vlad has also given specific yield, which is the right answer. We had discussed about what specific yield is earlier. It is nothing but the amount of water that is drained out as a result of gravity. So if we so it can be extracted by, if you apply a gravitational effect to this soil sample, water that can be extracted as a result of gravity is called the specific yield of that soil stratum, and it is expressed as the percentage of the volume of the water that is drained as a result of gravity to the volume of the aquifer, to unit volume of the aquifer. Now there are a few other terms also of importance over here. It is, first one is available water. Available water is nothing but whatever amount of water that is stored in the soil. Like some water will flow out as a result of gravity, some water will be retained. Whatever water that is retained, if it is available to plants readily, that water is called available water. Now available water is a very common term, so we can say that water which is available, but water which is available to plants in a soil profile is what is called as available water, or we say it's plant available water. So that is the term available water. That is what the term available water means. Then there's another term, field capacity. It is again the moisture, soil moisture content that is retaining back after excess water has been drained away from the soil. This is also another term for specific retention, but field capacity, we don't talk about whether it is an aquifer or whether it is a confined aquifer or an unconfined aquifer. We talk about a soil sample, whether it is an aquifer or not an aquifer. If you consider a soil sample, what is the water that is retained in it after gravity is called as a field capacity. Pellicular water is nothing but, the picture here will give you a more idea about what pellicular water is. So again, there are various kinds of water. There's capillary water, there is hygroscopic water, there's pellicular water, there's free water. So if this is a clay particle or a sand particle, as a result of this molecular attraction capabilities of the soil, it will hold some water to the surface of the soil particle. That water is called hygroscopic water. Now that water is remaining, it cannot be extracted. This is being held by the soil particle very strongly, so it cannot be extracted. Now thin film of water that is formed over this hygroscopic water is called the pellicular water. Now outside of that, whatever water is available is what water we can extract if we put in some pressure and all. So that is around what pellicular water means. It's thin films of water that is clinging to soil and rock particles above the water table is called as pellicular water. Okay, again, moving on to another question, which is about this formations. I think everyone will be familiar with what these terms are because we have done a couple of questions relating to it. So this question is about a formation through which only seepage is possible, as it is partly permeable and the yield is very insignificant. What is it called as? Is it called as an aquifer, acutad, acuflude, or acuflude? Take your time and think about the four formation which gives the significant yield water, which gives water but it is not significant, which does not give water at all, and which can retain but cannot. Okay, Ishwar has given acutad, Vagisha has given acutad, Twad, come on, the Twad lead. No, Twad is there. What's your name? Twad. Nice name, by the way. So, yes, Twad has given D, probably because you joined late and you were in there for the discussions. But never mind, we'll again go through the four terms: aquifer, acutad, aquifuge, and acuflude. So we got three answers. Great work, guys. So there we go again about aquifer, acutad. So the correct answer is acutad. Again, just for people who came late, what these four formations are. Aquifer is the best formation for groundwater. It can retain water. Also, when you dig a well or something, if you're digging it into an aquifer, we can extract a lot of water. It yields a lot of water. It can supply a lot of water. Such a formation, a permeable formation, is called aquifer. Examples of aquifers are sand and gravel. They human I think sandstone, limestones are also good aquifer material. I don't know. I think gravel is the best aquifer material. So that's about aquifer. Acutard is a formation. It's not as good as an aquifer. It consists of water. It can also yield water, but it is not as good as an aquifer. It is seepage and all is possible, but yield is comparatively less. Examples for this is clay lenses integrated with sand. Now, acute fluid are impermeable formations like clay. It can retain water. It is retaining water again because of its molecular attraction. And if pore spaces are there, water will stay there, but we will not be able to extract water from there. So it will not help in transmitting water, nor it will yield water. Acute fluids are completely impermeable formations which cannot hold water itself. So these are the four types of geological formations which will be repeatedly asked, like which one is which one is which, in many questions. Okay, so that is about the formations. Let's move on to the next question. This is also something that we discussed. Types of rock. Here they have asked igneous rocks that are found below the surface are called as what? So we learned about three types of rock: igneous, sedimentary, and metamorphic. Examples also we checked. There was something we discussed about igneous. Pakisha has given plutonic. Any more answers? Wad has given volcanic. Is your name Twad, or is it something else? Is this a short form for four big names? Okay, you don't have to answer it if you're uncomfortable. I was just asking. Okay, we got. Okay, Ishwar has given A, which we'll see is right or wrong. So yes, it is plutonic or intrusive rocks. We had learned about igneous rocks, which are formed as a result of solidification of magma or lava. Crystallization also can happen. If it is beneath the surface, it is called intrusive or plutonic. If it is above the surface, it is called extrusive or volcanic. Volcanic extrusive. Gabbro is nothing but an example of igneous rock. So here you can see crystallization means crystals are being formed in these rocks. So if it is happening under the surface of the earth, it is called intrusive, and when it is formed on the surface of the earth, it is called volcanic rocks. So just to summarize, we studied about three types of rocks. What are the examples of rocks? Can you just tell me another rhyolite and gabbro we saw now? Two other examples of igneous rocks. Yeah, granite is here. Okay, let's move on to the next question. What type of an aquifer does not have a free water surface? So we learned about four formations: aquifer, acutard, aquinclude, and aquifuge. Now in aquifer itself, there is two categories. We'll be learning about that. Please type in whatever answers you know. This Twad says C. Okay, the question is, what type of an aquifer does not have a free water surface? Okay, so let's move on to the solution. Yes, the answer is confined aquifer. So aquifers are of two types, confined and okay. Aquifers are of two types, confined and unconfined aquifer. Confined aquifer is nothing but when the aquifer is sandwiched between two impermeable layers. Say consider there's one clay layer on top and clay layer on bottom, and in between, if you have an aquifer, if you have an aquifer which is confined between these two impermeable formations, it is called confined aquifer. Unconfined aquifer is when you have when there is no top boundary for the aquifer. There's no pressure there. The water on the top or the aquifer on the top is subjected to atmospheric pressure. So such aquifers are called unconfined aquifer. So unconfined aquifers are the ones which have got the water table. The water table, since it is the one that is comprising of the water table, it is also called the phreatic aquifer, unconfined aquifer, water table aquifer, or free water surface aquifer. So these four names are there for unconfined aquifer. Why? Because it is the one which is having the water table. So it is also called phreatic, unconfined, water table aquifer, free water aquifer. And the water table is at atmospheric pressure. Whereas in confined aquifers, it is always having pressure that is greater than the atmospheric pressure. So if you pump or if you drill a hole, if you drill a tube well or something into a confined aquifer, there will be, since it is under high pressure, water will gush out. Such wells are called artesian wells. We had checked it out in the last week's session. So that was this about this question. Sorry, this is a very repeated question. Can you please repeat pressure line? Okay. Pressure, I'll come to it. There is another slide that is actually giving us, yeah, I'll come to it. I'll show a picture of it and explain to you. Now, with what is the upper surface of the zone of saturation called? Water table. Vagish also water table. Right, Ankita. Okay. Let's move on to the solution. So it is called water table. So as you can see over here, when you take a soil, I mean, when you take an area and when you go to the subsurface, initially there will be topsoil, then it will go some, as you go down, that zone is called the Vadose zone. Water will enter that, but it won't retain that, it will keep flowing down as a result of gravity. Then there is this layer where water will all accumulate, and those places are called zone of saturation. It will be fully saturated. So this layer, that is the top surface of the zone of saturation, is called the water table. Water table is nothing but that highest level, or again it is the zone of separation, but it is the line of separation between the unsaturated zone and the saturated zone. Saturated is nothing but entire pore spaces of the soil between the soil particles are filled with water, and if you keep adding more and more water to it, the level of the water will keep on increasing and coming. So such a condition is called saturation. Saturation means all the pore spaces in between the soil is fully filled with water, and the top level at which the water is available is called the water table. Now above that, I mean the soil portion above this water table will be unsaturated zone, or probably there will be a small portion which as a result of capillary action will have saturation because of this capillary water. But above all that, it is called the unsaturated zone. Water is not retained over there fully. I mean, it will have partial water, but not full water. The pore spaces are not going to be entirely filled with water. So the question was, Sorry. Question was, what is the upper surface of the zone of saturation called? It's called the water table. Moving on to the next question, which among the following is not a good example of aquifer? Is it granite, gravels, limestone, sandstone? Okay. So here we've been given with four options: granite, gravels, limestone, sandstones. In an earlier question, we had checked what is the best example what is the best examples for the rock type that holds the maximum of groundwater, and we understood that it is gravels. So here the question is, which is not a good example of good aquifer. So it's not gravel. We can't. I mean, option B is not an option. Granite, on the other hand, we know is an example for aquifuge, which is an impermeable formation which cannot retain water, neither can it transmit water. So the answer will be granite because it is an example for aquifuge, while sandstone, gravels, limestones can retain water and transmit water. They're all examples of aquifer, I believe. Now, what is the isolated water table that is held by a small extension of impervious rock called as? Okay, TWAD has given option C. Okay, Vagisha is saying it might be first. Ankita Ishwar, you have an answer. Okay, so right, like so many of you told, it's called perched water. Let's see what a perched aquifer is. We talked about aquifers. Vaisha, I'll be telling about the pressure thing also here. So perched aquifers are nothing but, you can see over here, I said unconfined aquifers are aquifers which are not having any impermeable formation on top. So what happens is, it is not under pressure, because when the water is coming under two water is I mean the aquifer is coming in between two impermeable formation. As more and more water comes, it is not having an option to drain off, so the pressure will keep on increasing over there. Such types of aquifers are called confined aquifers. When it comes to unconfined aquifers, on the top, like you see here, there is no barriers over here. There's no impermeable formations over here. So water will keep getting accumulated and accumulated and accumulated. Water table will keep rising and rising and rising. And all this portion with a water table on its top is called the unconfined aquifer. So unconfined aquifer is nothing but soil formations that is fully saturated with water. Only thing, there's no top layer that is binding it. As a result of it, it will be under atmospheric pressure. The water table is exposed. Actually, there is no pressure on top of the water table, so it is under atmospheric pressure. But when you see the confined aquifer over here, it has got a confining unit. Like it can be an aquifuge, or it can be a clay layer that is sandwiching this aquifer material in between the two confining units, which is actually resulting in a pressure that is developed in this confined aquifer. So when a question comes, what is the pressure on the water in a confined aquifer? There is some amount of pressure. In an unconfined aquifer, the water will be having only atmospheric pressure on it because it is open. There's no confining on it. So that is why when that is what I said. This is, you can see, flowing artesian well. When you pump a well or when you dig a well into a confined aquifer, because water is under a lot of pressure, water will come gushing into it because of that pressure. Okay, so perched aquifer here again. Sometimes there will be impermeable formations in between the soil, which will get accumulated, small formations like this. These are also confining units. Water will accumulate on top of it, and then after a point of time, it can flow off or it will get accumulated. These small formations are called perched aquifer. So this picture is pretty. You can understand the concept of confined and unconfined aquifer from this picture itself. You can see these small formations, impermeable formations, which accumulates water on top of it, is called perched aquifer. This large impermeable formations, which does not have a confining unit on top of it, and the water table is formed, is called the unconfined aquifers. And these confined aquifers are the aquifers that are formed between two impermeable formations. About a confined and unconfined aquifer. To the next question: which types of highly porous? Is it igneous rocks, sedimentary rocks, metamorphic rocks, or igneous and metamorphic rocks? Again, we studied about what all these three types of rocks are. How are their structures varied? Vagisha, I hope I was able to explain about the pressure thing. Are you clear about it?
Yes.
Okay.
Yeah. Thank you.
Yeah, no problem. So, which types of rocks are highly porous? Okay. Again, it is right. Right, Ishwar. You're also right. It's sedimentary rocks. So, sedimentary rocks are porous when compared to igneous and metamorphic rocks. Again, the porosity depends upon how they are packed and the arrangement of the particles. But out of the three types of rocks, it is sedimentary rocks which are high porous. So that was the last question, I believe, for this week's section. Now we'll do some problems that were provided in the assignment 0, that is related to this portion. So one question, the question 4 in the assignment 0: ability of an earth material to transmit water is a measure of porosity, aquifer characteristic, chemical cement, or permeability. So permeability is the most important parameter in groundwater. So it is based on the ability of this water to transfer water through it that will decide what kind of aquifer it is, whether it is aquifer, aquifuge, aquifluid, or tard. So permeability is the most important variable, and it is the ability to transfer water. Like this explains how easily water can flow through the rock or soil material, and how easily we can extract the water for our purposes, is determined by the permeability of the material. So that permeability is the factor that determines what kind of geological form it is also. So the question answer is permeability 0. Then there's another question. Question number 9. Groundwater is a subordinate of surface water. The answer is no. You cannot decide which is better. You can't say that groundwater is better than surface water or surface water is better than groundwater. It is all based on, there are a lot of variables when it comes to, deciding this factor. Nothing is better than the other or badder than the other. So the statement here is false. Groundwater, it is not a subordinate to surface water. Then there's a 10th question. The boundary between saturated zone and unsaturated zone is called the water table. Again, this is about what is the top layer of the zone of saturation called as. So that is called as water table. Question number 10 in the assignment 0. So these were few questions that were discussed from the from this week's portion in the assignment 0. Your submission dates for assignment 1 and 2 are yet to come. I believe it's on the 9th of August. So once the submission dates are completed, we'll be able to discuss the answers of the assignments also over here. This will be a good session. Okay, no issues. You can get done with today's session. If you have any doubts or you want to discuss anything about the portions that we have discussed today in this problem solving, I'll be here for some more time. Other than that, you're free to go. Thank you for attending today's session, Nankita, Adishwar, Pagisha. So please let me know if you have any doubts. If you were late in the class, maybe we can go through the first initial problems also if you want. I'll be here for some more time. Video lectures as well as the PDF of these presentations are uploaded and it will be shared with you. You will be getting it soon. About the all every week's problem solving sessions, the video of it, the YouTube link to it, as well as the presentation will be shared with you. You will be able to access it whenever you want to. Yes, Ishwar, we are done for today's class. If you have any doubts, you can ask or anything else. I'll be here for some more time. We have time till 5 o'clock, so I'll be here until you have any doubts or anything. Again, the video lectures will be available to you. The presentation also will be available to you. So if you have any more doubts later on also, you can ask in the forum or in the next class. Whichever way is fine. Thank you, Ishwar. Thank you for attending the class. Hi, to add, I mean, if there's nothing more to discuss, um, you I think there's a new entry. Akash. Akash, I think you entered a little bit late. Do you want to go through the questions? We have time till 5 o'clock. Hello, Akash. Next word. They are yet to share it with you. They'll be sharing it with you soon. They'll share your Google Sheet. It will be there in the Swayam portal itself. There'll be a link to the sheet. They'll be sharing it with you very soon. I will not be able to share it with you personally. So don't worry, it is always shared. That link will come in the portal. Like I said, the link will come in the portal very soon. They'll be sharing it with you. In the NPTEL portal itself, there will be a link to the live sessions as well as the presentation material. They are yet to share it with you. Okay, that will be it for today's session. Thank you for attending the session, and we'll see you in the next week. Have a good evening. Bye-bye.